Good morning. It's Brian here again with ECC, and today we're going to talk about generic OBD2. And to access generic OBD2, I'm going to use the OBD2 direct function on the scan tool. And the OBD2 direct function is going to take me in to my 10 modes of OBD2. So let's go. So I have two options here. One is OBD2 Diagnosed. That'll take me into all of my generic OBD2. The other is OBD2 Health Check, which is only going to take me in and it's going to look at what are called the monitors, which is actually in mode 1, but normally called out as a separate function in the scan tool. We're going to go into OBD2 Diagnosed because that'll give me access to all 10 modes of OBD2. All 10 modes are not supported on this vehicle, but I'm still going to go to that menu choice. So it can give me connector information, protocol selection. I'm just going to click Start Communication. And the cool thing about this tool is it's going to find the communication protocol and start talking. And it just came up and it told me that it found one electronic control unit. If I'm working on a hybrid vehicle, I might find 2 or 3. It gives me the protocol it's using, in this case, a controller area network, which makes sense. It's a 2012, so that's what it was required to use. It gives you my ID, and it also gives me my VIN number, which is required on all cars 2005 and newer. So I'm going to click Continue. And here are my modes. So I have readiness monitors, which is part of mode 1. It's my current data. I have my mill status, is the mill commanded on or off. That is also in mode 1, but it's called out here separately in the menu. So I have mode 1, which is current data, mode 2, which is freeze frame data, mode 3 is my confirmed diagnostic trouble codes, mode 4 is where I would clear my mission related data, mode 6 is my test results for my monitors, and mode 7 is my tests that have failed the last time they were tested or pending codes. Mode 8, request for bidirectional control, which doesn't work on this vehicle, but it is there in the menu. My read vehicle identification, so this is my calibration ID, my programming for my computer. My in-use performance tracking is looking at my monitors and how many times they've attempted to run and how many times they've successfully run. And then mode 0 is my permanent codes. So we're going to do a couple different things in this series. One is we're going to look at some of what's inside each of these, and then we'll actually set a code so we can generate a freeze frame, look at what's in freeze frame, and we'll look at how that works. Okay, so let's take a look at my diagnostic trouble codes, mode 3. I want to make sure I don't have any codes in there before I start messing with this vehicle, because that way when I'm done, if I have codes, I know it's something I did. If I don't check for codes ahead of time, then I may spend a whole bunch of time trying to fix something that was already present, thinking it's something I did. So I'm going to go into mode 3. Mode 3 is my confirmed codes. These are codes that can turn the check engine light on, and I have none present. So I'll click the back button. And then I'm also going to go into mode 6 and 7. And I'm going to do two things here. First of all, I'm going to look to see if I have any codes. I have no codes, so this would be my pending codes or things that failed their last trip. And I'm also going to look at some mode 6 data here. So my mode 6 data is directly related to my monitors. So before we look at that, let's look at our actual monitors. So my readiness monitors, and I'm going to look at monitors that are complete since the DTC was cleared. In other words, since I cleared the memory on this car last time, or someone else did, which monitors are complete. So this is what we look at if we're going to get a smog inspection. The computer's going in and looking to see which monitors are complete. So I'm going to click on that, and I'm going to see all the different monitors that are supported here by OBD2, and I have Misfire, fuel system, and comprehensive component are complete. Those are my continuous monitors. Now my non-continuous monitors that I actually have to worry about are catalyst, fuel evaporation, heated cat, secondary air, AC system, O2 sensor, O2 heater, and EGR. In this particular case, I have a couple of them up here that are never going to be used. Heated catalyst and air and AC system were never implemented by EPA. So even though they're in the software, they're always going to be not supported. The only exception is Audi did support the AC refrigerant system on a couple models, but it will not cause a car to fail smog. Here I have an O2 sensor. This is O2 sensor performance. This is the O2 sensor heater. I have my catalyst, my fuel evaporation system, and then I have EGR system. And the EGR system on this is unique because this car does not have EGR. This car uses variable valve timing to perform an EGR function. Therefore, this monitor is really my variable valve timing monitor. And if I look at the documentation from the Society of Automotive Engineers, it'll tell me that this monitor, that this space in the computer can either be EGR or VVT. The issue we have is the software and the scan tool only understands its EGR. Our scan tool is kind of like an address book. So our addresses in OBD2 are all based on a hexadecimal numbering system, and the scan tool goes to different locations thinking it knows who lives there. So as far as my scan tool is concerned, EGR is who lives at this address. I know from reading documentation, variable valve timing moved in with EGR, so if I have an EGR and variable valve timing, they both live here. In this case, this car does not have EGR. All it has is variable valve timing. So this is really my variable valve timing monitor, even though that's not what it says. So it's really important to understand more than just what the scan tool tells me and be confused. I need to understand how these systems are built and how they work. So this is my monitor status. Since my monitors are complete, I'm gonna have some pretty good mode 6 data. So if I back out of here, use the exit button, I need to exit again. I'm gonna come down to mode 6. Okay, so what I have here is I have individual tests. So here I have an oxygen sensor test bank 1 sensor 1, oxygen sensor test bank 1 sensor 2. These are both for my oxygen sensor monitor. That means that if I run the test for sensor 1 but not for sensor 2, the monitor will not be complete. So a monitor is a group of tests. It's not necessarily one individual test. I have to complete enough of those tests in order to complete the monitor. I can pass the test or I can fail the test, but I have to complete the test in order to do a monitor. So if I have a car that's not completing monitors, for example, the O2 monitor, I would go into mode 6 and look here and see which tests aren't run. If all the tests are run here, but none of the tests are run here, that means I have a problem with that sensor. That's not a problem with what we call enable criteria, actually being able to go run the vehicle. So this is really helpful when we look at catalytic converters or we look at other monitors by going in and looking at the pieces of the monitor and figuring out what is and what isn't run. We can help find out what the problem is. So let's take a look at some data here. And I can also go in, I got my catalyst, I only have a 4-cylinder, so I only have a bank 1 catalyst. I got my variable valve timing monitor, which is our EGR like we talked about earlier. Purge flow is part of my fuel evaporation. My O2 heater monitor, that is for just the heater monitor. And I got fuel system, so I've got some information here for the fuel system. This is non-continuous, this is continuous monitor. I have misfire data, which is continuous monitor data, and misfire general data. So this lower stuff is all part of my continuous system. Now, from 2008 on, all vehicles support single cylinder misfire data in mode 6. So that's pretty cool. So if I have a car that's running rough, but I don't have any misfire codes, I can go here and look. So if I come in here and I'm just going to take a look at misfire cylinder 1. So if I look here, it's telling me that it's ready and it's completed. And I've got a 0, a 0, and a 65335. So I have a value of 0, I have a minimum allowed of 0, and a maximum allowed of 65535. 65535 is like infinite, because in a 4-digit hexadecimal system, that's the highest number I can get. So I'm going to measure this whole range. What I'm really concerned about is 2 numbers when I look at this data. One is I want to see this max number of the 65535. That means it's tested it. Because if it hasn't tested it, I'd see zeros in all 3 places on a canned vehicle. So the fact that it has a number here means it's run the test. Yeah, it's telling me up here, but not all cars or all scan tools will tell me that. I need to understand if I see all zeros, it hasn't tested it. If I see a 0 and a max number on canned vehicles, it's run the test. The other number I want to look at is this number right here. And what I can tell you is, if that number is not 0, you have a misfire. That will not necessarily mean you get a code. Many times, in order to get a code, I may need to have hundreds here or even thousands here before it gets enough times to set a code. One example on an older pre-can Ford vehicle is that it had to misfire 33.4% before it would set a code. So if it only misses 33.3% of the time, you're not going to get a code, but you're sure going to have a car that runs bad. So I'm working on an Asian vehicle here, and it will not set codes for an injector that has an open circuit or is unplugged. It'll take a while to even set a misfire code for that. But it will count up misfires here very quickly. So I can find that out. I can see that. So this is great. This scan tool is not the best scan tool for Mode 6 because I got to go in and look at each of these individually, but I can get the information. There's other scan tools that'll give it to me all on one page. So depending on what I want to look at the car, I may want to use different scan tools. So I'm going to back out of this. I can also look at misfire general data. So this is looking at misfires for all my cylinders combined, and I can see I still have zeros, 65535. My car, even though it may feel like it idles a little rough, does not have any misfires. Well, if the engine is not misfiring, but I feel a rough idle, I need to start looking at things like motor mounts. I need to look at things like that because the car's not misfiring. So if I'm feeling something, maybe I have some motor mounts that have collapsed after 200,000 miles, and we need to look at that. So this is also a great way of looking at a car. When a customer complains that their car feels like it idles rough or runs rough, I can go into Mode 6, look at this data and figure out, is the car running rough or does the customer just feel the engine more because motor mounts are collapsed or other things are wear, or maybe the exhaust is touching or something like that. So this is our Mode 6. So I'm going to back out here and let's just look at my O2 sensor. So this is all part of the O2 sensor monitor. Remember, I got two sensors, sensor 1 and sensor 2. So I got to look at each of these tests if I'm the computer, and I got to go through and run all these tests before I'm going to complete the monitor. So if I come through here and see one of these tests with all zeros, that means it hasn't run the test. So as I scroll down here, I can see it tells me that it passed. What I can tell you is if it hasn't run the test, it's still going to say passed because we're not going to default it to fail. We're going to default it to pass. But this lets me know, not only did I passed by a really healthy number. So we can see here, these all happen to be max tests, means I can't go over the maximum. We also have a minimum number, I can't go below the minimum. So we have a range here for these tests. So I have some tests that are only max, only minimum. Some tests are going to have a bigger range. So I can look through here and see what I have. So this is great for figuring out what failed. So for each of these, I can go through and look at each of these tests. I can also take this test ID. I have the OBD2 mid 02 and the test ID 08, and I can go look that up in data and find out exactly what the computer did as this test. So if I have a test that's not running or a test that's failed, I can see exactly what failed. So this is really helpful when diagnosing codes because I want to know what the computer saw. What did the computer see that it didn't like? Plus, I can also use this to verify my repair on the other side because if I have a failed test, when I go run the monitor, now I can go look at the results and make sure I passed and I had a real healthy pass, not a barely pass or a fail. So this is in Mode 6. So we're going to play with this a little bit, and that the first thing I'm going to do is I'm going to clear my emission-related data. And when I clear my emission-related data, not only do I clear codes, I also clear my Mode 6 data. What I'm not going to clear is my in-use performance tracking. So I'm going to go in here and just clear emissions data for now. Actually, I'll look at emission control. Actually, we'll clear data. So I'm going to clear emission-related data, and it tells me I'm going to lose freeze frame, which I don't have any of right now, test results, my monitors I just looked at, diagnostic trouble codes, mill. What it's not telling me is I'm going to lose all my Mode 6 data. So I'm going to click Continue. Now if I go back into Mode 6 data, okay, so let's go back into our O2 Bank 1 Sensor 1 and look at how the data changed. Now I have, not only does it say not complete, but I have all zeros. So some scan tools will just say passed here. This scan tool, the software is a little bit better, so it says not complete, lets you know what tests aren't done. So depending on the generation and brand of scan tool, you're going to get different information. I can just look at the numbers and know it's not complete. They started adding more software because fewer people understand what this means, but they can understand not complete. So again, different scan tools are going to give you different information or different supplemental information. All generic OBD2 scan tools should be able to do this. Also, if you notice here, I'm looking at milliamps, here I'm looking at volts, here I'm testing volts. So it actually tells me what I'm doing. And that's true on all CAN vehicles. So let me back up a little bit. I'm going to look at mode 9, my in-use performance tracking. So my in-use performance tracking tells me how many times I've met the monitoring conditions for bank 1 catalytic converter and how many times I've completed it. So I've completed it 53 times, I've met the condition 51 on 309 engine starts. So I just put a new battery in this car a couple months ago, and when we lose battery power, I lose my in-use performance tracking data. So we're really not looking at the total numbers. What we're doing is we're looking at ratios. Out of this many engine starts, out of this many times I met the conditions, how many times did I complete? Out of this many times I met the conditions, how many times did I complete? Out of this many times I met the conditions, how many times did I complete? And so on. So there's a ratio that we look at to see if I've met the conditions so many times, how many times did I complete it? And all CAN vehicles do this function. So this is great. If I have a car that's not running a monitor, I can go in and look at here and go, does that monitor normally run, or does that monitor almost never run? Or has that monitor run like twice in the last 2,000 key starts? It probably needs more than a test drive to get that monitor to run. So this is a great way of looking at what the history of the car, and does the monitor normally run? Has it never run? Is there multiple monitors that have a problem? For example, my catalytic converter monitor might not run, but my O2 sensor monitors also hardly run. I probably need to look at the O2 sensors, since we use O2 sensors to run the catalytic converter monitor. Instead of wasting my time looking at the cat, let's go look at the O2s, because I can tell they're having a problem also. So this is a way of kind of looking behind the scenes and seeing how often from a ratio between our conditions to completions. And on a CAN vehicle, 2008 and newer, it's not uncommon to see the completions more than the conditions. If we're working on a vehicle older than 2008, we're not going to see that because the monitors are only run once per key cycle. So they changed in 2008 how we're able to run those. So what we're going to do now is I'm going to back up, and if I go into freeze frame, we will see I have no data here because I have no codes. And it says no freeze frame data available. So the reason why it says no freeze frame data available is there's no code present that has turned my check engine light on. So even if I have a code in mode 3, if my light's not on and I have no freeze frame data, the code there is not an emissions code that can turn the check engine light on. So before I set a code, I want to look at one other thing to show you, and that's my permanent diagnostic trouble codes. Now my permanent diagnostic trouble codes, I cannot erase. I can't erase them by disconnecting a battery. I can't erase them with a scan tool. Only the car itself can erase them by proving that the car is fixed. So if I go into permanent diagnostic trouble codes, I have no codes present. So what we're going to do now is we're actually going to set a code. So what I want to do is I want to set a code, and when I set the code, because it's going to be a hard circuit code, so it's going to be a one-trip code, I'm going to set a code in mode 7, mode 3, and mode 0A. So let's see if I can get it to set a code here. Okay, so I've just disconnected a camshaft sensor. The car is not running. This should be caught by my comprehensive component monitor, which is looking for opens and shorts. So let's go in and see if I have a code. So the first place I'm going to look at is mode 7, which is pending or current failed codes this cycle. And I'll take a look and let's see what we got. And I have a P0368 bank 1 camshaft sensor B code. Doesn't tell me what's wrong, it just tells me there's a code there. I would need to go to the diagnostic information, look that up. So now let's go down to mode 3. and I have the same code there. Because since this is a one-trip code, a circuit code, it's going to put it in here. It's going to turn the check engine light on, as well as it's still going to be in my pending codes, because pending codes are really failed their last test, and this car obviously failed on its last trip. So now let's go in and look at my permanent codes. And I have a permanent code. So I've set the code all three places at the same time. So now let's look at freeze frame. And freeze frame will tell me exactly when the code's set. So if I look at freeze frame data, now the EPA requires at least 8 pins be here, but many cars give us a lot more, especially on modern vehicles. And I can use freeze frame to help duplicate the conditions that set the code. So I can see here, like I said, my engine's not running, my engine speed's at 0. It gives me my absolute throttle position, relative throttle position, throttle is closed. And time since start is 0 because I didn't start the car. Tells me my intake air temperature is 109, so it's a nice warm day. And my coolant temperature is 95. Airflow, grams per second, 0.42 is a default value, but if I was running down the road, it would give me a number there. It shows my barometric pressure, 28.9. And so again, it's going to give me some O2 voltage. It's going to give me my long-term and short-term fuel trim. And I should be able to scroll down here. Distance since miles cleared. 0 miles since, because we just cleared it. Vehicle speed, catalyst temp. So you can see we have a lot of information that I can use to help diagnose the vehicle or to figure out what conditions when this is happening. This is especially important if it's an intermittent fault, or if it's something like a catalytic converter code, when did the car run the monitor and set the code? If it's a fuel trim code, what were the fuel trim values and how fast was the car going? How many, and what was the airflow? What was the engine RPM when the code set? Did it set at idle, or did it set at cruise? Did it set on a cold engine or a hot engine? This is where I get all that information. So as I back out of this, now I'm not going to have any mode 6 data for this because this is a continuous monitor, not a non-continuous monitor. So I don't have anything useful there. So now what I'm going to do is I'm going to clear my codes again. Okay, so let me click continue here. And let's go back and check our codes again to see if we actually cleared the code. So it says my diagnostic data has been cleared. So now let's go look at codes again. And the code didn't clear. Well, why not? Well, actually the code did clear. And this is a mistake a lot of technicians make. They think the scan tool is broken. No, the code reset right after I cleared it because I still haven't plugged the sensor back in. So technicians, a lot of time, we call this a hard fault. A lot of times technicians misdiagnose a hard fault as a scan tool that won't clear the code or a problem with the computer. They're not understanding that the fault is a circuit code. It's covered by the comprehensive component monitor, and it's happening all the time. So as soon as I clear the code, the computer rechecks the circuit and says, hey, I'm still broken, I'm gonna reset the code. So many people mistake that as a code that won't clear. In actuality, we did just clear the code, and the code reset before I could go ask for codes again. So this time I'm gonna plug the sensor back in, and we're gonna clear codes again. And mode 4 is to clear codes. And it says I cleared, so let's go back to mode 3. And no code present. So just like I said, a circuit code can set that fast, and it can make you think your scan tool's not working. In actuality, you have a hard circuit fault. Hard circuit faults are among the easiest thing to diagnose because it's a simple electrical circuit code. Get the information that set the code for which circuit's out of range, get the wiring schematic, and troubleshoot the circuit. So if I look here, that's mode 3. If I come into mode 7, my pending codes, we'll see I have no code. Now let's go to permanent codes, 0A. I still have a code here because even though I've reconnected it, the computer's not convinced that we fixed the car. This permanent code is what causes a car to fail smog today. Even though the check engine light's off, even though I've cleared things, even though I think I've dotted all my I's and crossed all my T's. If I have a permanent code here, this car is still going to fail smog. Now this code will go away when I run the other monitors and the car is satisfied that the circuit's been working long enough and it's tested it multiple times, it will clear the code. But it'll stay here until the computer on the car is happy. Disconnecting the battery is not going to get rid of this code. My scan tool is not going to get rid of this code. This code's here until we fix the car. So if I come out here and go back to my in-use performance tracking or IPT tracking in mode 9, I can see right here this hasn't changed because I haven't cycled the key. I haven't run any monitors. But by the same token, the data is still here because unless I disconnect the battery, I'm not going to lose this data. Now let's look at vehicle identification. So this is also in mode 9, and this has a lot of information. It has my VIN number that we already saw, has my calibration identification. So this is the software version that is in the car. So I might have a TSB that says reprogram the computer if it doesn't have this software version. This is where I'd go find that. This is a calibration verification number is the next thing we're looking at, our CVN. This is matched to the calibration. This is something that the state looks at when we do a smog inspection to make sure that the calibration verification number is for the calibration on the vehicle. If not, it may fail a smog inspection or be required to go to the referee because there's something wrong with the software. Here's my ECU's acronym and test name. So in this case, I know it's the engine control module, but if I had a transmission control module and a hybrid control module or a hybrid battery control module, it would list the different modules here and tell me what each of their names are. Engine serial number is not supported on this vehicle, neither is the exhaust type or the other issues that we see here. So none of these are serviced on this 2012. We're constantly expanding OBD II. More and more features. If you don't know it's there, check it. Worse is going to come back and say it's not supported. That's how you learn what's there. You're not going to hurt anything poking around. So hopefully this gave you a great overview of how we use OBD II, what I'm going to find in each of these areas, and how it's going to work. And the OBD II, these generic numbers are the same for every scan tool. This is a snap-on scan tool, so it's giving me the mill status and readiness monitors on a separate page. It also gives me a troubleshooter function where it allows me to go on and give me some diagnostic help. That's unique to Snap-on. That has nothing to do with OBD II, that has to do with the tool manufacturer. But this OBD II is a powerful tool. Keep in mind, we'll get different information here than I will get on the manufacturer side. But all vehicles are required to have OBD II, and keep in mind, only codes in mode 3 can turn that check engine light on. So if you're fixing a car with a check engine light on, you better be stopping off at OBD II generic side and seeing who actually turned the light on. Don't just jump it on that manufacturer side and get lost. So hopefully this has been helpful for understanding global OBD II and how to poke around and find valuable information to help you fix the car. Thank you.